Here's sample test problem number 4. The dense drill starts from rest. At the 3.2 seconds of constant angular acceleration, it turns at a rate of 2.51 times 10 to the 4 revolutions per minute. Find the drill's angular acceleration. Well, we need to know 3 rotational kinematic variables so we can find the fourth. So what do we have? It starts from rest, so the initial angular velocity is 0. We know that we're going to have a time of 3.2 seconds, and the final angular velocity is 2.51 times 10 to the 4 revolutions per minute. That would be our 3 variables, except we want to change this last one into radians per second. So we know that there is 2 pi radians per revolution and 1 minute per 60 seconds. That would do it. So minutes would cancel out, revolutions would cancel out, and if we do that, we get 2,628.5 radians per second. Sounds good. So now we got the 3 variables we need. We want to find the angular acceleration, which is our 4th variable. So we're going to use rotational kinematic equation number 1. Final angular velocity equals initial angular velocity plus angular acceleration times time. So our angular acceleration will equal the final minus initial divided by time, which will be 2,628.5 minus 0 divided by 3.2 seconds. And that's equal to 821.4 radians per second squared. So that is our angular acceleration for this drill. Part B, determine the angle in radians through which the drill rotates during this period. We now know 4 rotational kinematic variables, so we can find the angle pretty easily. Even if we didn't know the angular acceleration, we would use rotational kinematic equation number 2, omega naught plus omega divided by 2, average angular velocity times time, which would be 2,628.5 plus 0 divided by 2 times 3.2, and that's equal to 4,206 radians. Sounds good. Here's part C. How much pain does the patient feel? Well, we know that if the patient is feeling pain, it has to be directly proportional to the amount of kinetic energy that the drill has, somewhat mitigated by the amount of Novocaine applied to the patient. This will all be accentuated by the amount of screaming heard in the next room as somebody's feeling pain there, and also accentuated by the sound of the drill in general, somewhat mitigated by the amount of sound that the TV makes in the room. But of course all this is going to be exponentially increased by the value of the bill that you're going to receive when everything is done. So this is the way the science is done for the amount of pain. We can't really figure out the pain. So that's just a subjective question. So no answer for that one. It's going to feel a lot of pain. Okay.